You know when you pull up a map on your phone? You can just pinch and zoom in on any street, any building, literally anywhere on the entire planet. And it all works because of two simple numbers. Today, we're going to break down the brilliant and honestly, surprisingly simple system we invented to give every single spot on Earth its own unique address.
Okay, so let's really think about this. This was the big puzzle. Imagine you've got a perfectly smooth ball, right? How do you tell someone exactly where to put their finger? Now just scale that ball up to the size of our planet. That's the massive challenge we had to solve.
And you know what the solution was? It's kind of wild. We just made it all up. The entire system that powers everything from your GPS to global shipping, it's all built on a set of imaginary lines that all of humanity just collectively agreed to draw all over our planet. So, if we just invented this whole grid, how in the world did we decide where to even start drawing the lines? Let's unpack this planet-sized puzzle piece by piece.
Well, the first step was to find some kind of reference point. And luckily, the Earth gave us a couple for free. You see, it spins. And the points at the very top and very bottom of that spin give us two natural anchor points, the North and South poles. The imaginary line connecting them, that's the axis. It's not a physical thing, but it's our starting point.
All right, so with the top and bottom of our planet locked in, it was time to draw the single most important line on our imaginary map, the one that would slice the world right in half. And that line is, of course, the equator. It's the only one like it, perfectly splitting the Earth into the northern and southern hemispheres. So we designated it as 0 degrees, the ultimate starting line for measuring anything north and south. Now, from that 0-degree baseline of the equator, we can draw a whole series of parallel circles, kind of like stacking rings on a globe, all the way up to the North Pole and all the way down to the south. We call these the parallels of latitude, and they let us measure, in degrees, just how far north or south any spot is. Awesome, so we figured out the north-south problem. We can find any location along a north-south line. But does that really give us a unique address? Is our puzzle solved yet? Nope, not even close. I mean, look at this. The Tonga Islands, way out in the Pacific, and the Mauritius Islands in the Indian Ocean are both at 20 degrees south latitude. If you told a ship's captain to just sail to 20 south, they'd have no idea which side of the planet to even aim for. We're missing a whole other direction, east and west.
And this missing east-west direction, well, it turned out to be a much, much trickier problem. And why is that? Because unlike the equator, there's no natural place to start counting from.
Just think about it for a second. The equator is totally unique, a natural dividing line. But for east and west, there's just nothing. You can draw a line from the North Pole to the South Pole through literally any city you want, and it's just as valid as any other. So where on Earth do you decide to start counting from 0? This is where that global agreement became absolutely crucial. After a lot of debate, back in 1884, the world finally decided that the line passing through the Royal Observatory in Greenwich, London, would be our official starting point. That became the prime meridian, 0 degrees longitude. All east-west measurements would now start right there. Okay, now we have both pieces of the puzzle. We've got a way to measure north-south, and now we have a way to measure east-west. It's finally time to put them together. So let's put our two pieces together. On one hand, we have our horizontal lines, latitude, that tell us how far north or south we are from the equator. And on the other, we have our new vertical lines, longitude, telling us how far east or west we are from Greenwich. And when you overlay these two sets of lines, boom, you get this, a perfect grid. Each and every intersection, where a line of latitude crosses a line of longitude, creates a single unique address for any point on the surface of the Earth. The planet-sized puzzle was finally, elegantly solved. To make this super clear, let's look at a real example. The town of Dhubri in Assam, India, can be pinpointed exactly where the 26 degrees north latitude line crosses the 90 degrees east longitude line. A perfect, one-of-a-kind address. But believe it or not, the story doesn't stop with just a location. This imaginary grid had a really powerful and unexpected side effect. It became the key to standardizing something else we all live by, time itself. So, as this quote suggests, the way we measure time has always been tied to how our planet moves. I mean, when the sun is at its highest point in the sky, it's noon, right? but highest in the sky happens at a different moment depending entirely on your longitude. The math here is actually pretty simple. The Earth spins a full 360 degrees in about 24 hours. If you break that down, it works out to 15 degrees of rotation every single hour. Or, if you want to get even more granular, that's 1 degree every 4 minutes. This direct link between longitude and time has some huge consequences. For example, inside a single large country like India, the local sun time can be completely different from one side to the other. If every town just used its own local noon, the time in Dwarka on the west coast would be about an hour and 45 minutes behind Dibrugarh on the east coast. Can you imagine trying to run a train schedule like that? It would be a total nightmare. And that's exactly why countries created standard time. And this explains global time differences perfectly. India's standard time is based on a line of longitude that's about 82.5 degrees east of Greenwich. Well, that difference in longitude translates directly to a time difference of 5 hours and 30 minutes. So when a cricket match starts at 2 p.m. in London, it's already 7:30 p.m. in India. It's all just math based on longitude.
So this elegant grid of imaginary lines didn't just give us addresses. It synchronized our entire world. The next time you use your phone's GPS or track a package sailing across the ocean, just remember, it's all built on this simple, brilliant idea that solved a planet-sized puzzle.